So I think you're talking about one that ended up looking like ln of x to the fourth power. Is that right?
Yeah.
And so I wrote that like this, perhaps ln to the fourth of x. This means the same thing. But this does not equal 4 ln x. Right? 4 ln x means ln of x to the fourth power.
Okay, got it.
Yeah. So it's got to be the argument of the natural log. So the thing that you're taking the natural log of has to be raised to a power to pull that power out to the front. Whereas in this case, what this means is this means natural log x times natural log x times natural log x times natural log x, right? 4 natural logs, not the natural log of x times itself 4 times. Does that make sense?
Yeah.
Cool. Any other questions from any of the stuff with the separable differential equation?
Will we have more practice before the quiz, or is like the questions it?
Oh, I don't know. I guess I could try to find some time to put a few extras up today. I'll try to get some extras up this afternoon sometime.
Thank you.
Yeah. So we'll do that, a few extras, and that way you'll have something else to go over. I probably won't put up an answer key for them, but I'll go over any questions anybody has on them in class tomorrow. So.
I actually have another question.
Okay.
For number, I think D, it was ln's absolute value of sine y equals x to the fourth minus 1. And then you exponentiate both sides. And how do you get rid of the absolute value of the sine? Because I saw you just took the inverse sign, but would you need to put like a plus or minus?
I had ln absolute value of x equals what?
And it was ln sine y equals x to the fourth minus 1.
Ln absolute value sine y equals x to the fourth minus 1, right? Yeah, okay, so I exponentiated, right? And I got absolute value sine y equals e to the x to the fourth minus 1. And sorry, so what is your question? How did I get rid of the absolute value?
Yeah.
Okay, so I may have not written it fully out. We get rid of it by getting rid of it and putting a plus or minus in front of this. But then we have to look back at the initial condition that was given to you. So what was the initial condition?
Y equals pi halves, and then x equals 1.
Okay. So with x equals 1, y equals pi over 2. So the sine of pi over 2 equals either positive or negative e to the 1 to the fourth is 1 minus 1. And so sine of pi over 2 is 1, right? And we have plus or minus e to the 0 or plus or minus 1. So we have to choose the positive, not the negative.
Okay, got it. Yeah.
Does that make sense?
Yep.
Cool. Yeah. And so then you take the inverse sign and get your answer.
Why do you choose the positive one for this one?
Because of the initial condition, right? We plug in
okay.
pi over 2, we get 1 over here. So we have to get positive 1 over here, not negative 1. Does that make sense?
Yeah.
Okay. Anybody else? Any other questions on the separable differential equation stuff? Yeah, it's a really important thing to keep in mind. When you clear the absolute value, you put the plus or the minus, and then you look at your initial condition and choose the right one that's appropriate based on the initial condition. Happens a lot also when you end up taking the square root of something on the left-hand side. So you take the square root of the thing over here. You still get a plus or minus over here. So you gotta do the same. You gotta go through and choose which one is correct, either the positive or the negative square root. Anything else? All right. So we went through and we did some problems where we were looking for the area underneath the curve. And we had some where the function went below the x-axis, and we had to deal with that by splitting it up into multiple integrals, right? We did that. All sounds familiar and wasn't too terrible.
Yeah.
All right. So today, we're going to look at a situation where we've got one function, we'll call it f of x, and we got some other function, we'll call it g of x. And rather than wanting to find the area underneath f of x or the area underneath g of x, we want to find, that's not very easy to see, let's use a better color. We want to find the area between the two curves. Okay. So anybody see a nice easy way using integrals to find that value from a to b, the integral, the value of the area between f and g?
Integral of f of x of that interval minus the integral of g of x of the interval.
Yeah. Do the integral from a to b of f of x dx minus the integral from, that's not an a, from a to b of g of x dx. Right? Because if I were to just do f of x, right, f of x would be this, right? And g of x would be this. And so if I'm going to do f of x, that's going to give me everything in red, and g of x will subtract off all the stuff that I, did across with orange, which will just leave me with the stuff in blue between the two of them. Make sense?
Yep.
Yeah. And so if we wanted to, rather than do this as two separate integrals, since these have the same limits, one of the rules for integrals was we could, if we had a minus or a plus between them, we could combine them into one single function and integrate it that way. And so sometimes if there are some common, common terms in here that we could combine together, that might make our integral easier to do rather than having to do like a 3x here and an x here. Well, it'd be nice to just combine those into a 2x, 3x minus x, and so on. So this ought to give us the the area between two curves. Yeah? That seem reasonable?
Yep.
Oh, good. Okay. Well, is it that simple though? What if I have f of x? And now g of x is down here below the x-axis. And I want to find the area between f of x and g of x from a to b. Can I still do the integral from a to b of f of x minus g of x? Does that still work? Well, what's the integral from a to b of f of x? That's everything below f of x and above the x-axis, right? True?
Uh-huh.
So that gives me part of it. What is the integral, or what is this area? This area should be this is the integral from a to b of g of x, right? Except that the area itself is positive, but the integral is
Negative.
negative. So this integral is a negative value. So if I take this integral, which is negative, and subtract it, what does that effectively do? It makes it positive, right? And so it would appear that this integral of f minus this integral of g should make this minus a negative and make this come out as a positive value, which should give us the entire area between the two curves. So it looks like it does still work, right? If one function is always above and the other function is always below. Yeah? Agreed or no?
Agreed.
Wonderful. All right, so both functions above, good. One function above, the other function below, good. All right, well, what about here? There's F, there's G. What if I still want the area between the two of these, but now they're both below the x-axis? Can I still do the integral from a to b of f of x minus g of x, or not? Find this area here. What does the integral from a to b of f give us? The integral gives us this section, right?
Yes.
And let's call that section, let's call that piece of it capital A. All right. What does the integral of g give us? It gives us all of this, doesn't it? We'll call that capital C area. And let's call this thing inside of here B. So what is the integral of f give us in terms of a numeric value?
A plus C?
No, just of f. Just of f. It's just as a, right? Except the integral itself is the opposite of that area, a, isn't it? True?
True.
Okay. Minus g, well, g gives us c, right? Minus the value of c, but it gives us it as an opposite, doesn't it? Right, because c is the positive area, but this integral is negative. So effectively, what we get here is positive c minus a. And c is equivalent to what? A plus b. True? Which would tell us that a plus b minus a is what we would get if we do this integral. And what's a plus b minus a?
B.
B, which is exactly what we wanted, right? We wanted B, the area of this. So A is the area of this region, B is the area of this region, C is the area of both of them combined. And just by using what we know about integrals, the integral of f is the opposite of A, the integral of g is the opposite of C, being A plus B, we should show that this should still work, even if they're both always below the x-axis. Everybody good with that?
Yes.
All right. But what if here's A, and here's B, and here's F, and here's G, and I want to find this area. Will that work or no? Can I still do the integral from a to b of f of x minus g of x?
No.
Is that a yes or a no?
I would think no, since it crosses over into the negative side. So
All right, so let's think about this. Let's break it down. From here to here, from a to whatever we want to call this value, I've got one function that's always below and the other function that's always below. True? So should it work in this section right here?
yes.
That's for a to here. Yeah, this section should be okay. All right, well, from here to here, in fact, I'll just do that. I have one that's always above and one that's always below. Does it work then? One above, one below. Does it work?
Yes.
So it should be okay in here. And this one, I got one above and the other one also above. Does it work for that?
Yep.
So this just meets all three criteria, or all three of the cases that we just did. Both below, one above, one below, both above. Should be okay. So yeah, we should be able to utilize this again. The only thing that will cause this to be an issue has nothing to do with the x-axis. It only has to do with suppose f and g intersect on the interval. Right? If they intersect with each other on the interval, sometimes f is above g and sometimes g is above f. So I would have to find this point of intersection and to find the total area here, the red plus the blue, I'd have to do the integral from a to c of what minus what for the red?
G minus f.
G of x minus f of x, dx. And then add to that the integral from c to b, in this case, f of x minus g of x dx. So the only time we might have to do anything special with these is if the functions cross through each other on the interval that we're looking at, giving us one function above the other for part of it, and then vice versa for the other portion of it, for interval. Good? Makes sense? Any questions on that?
When using the formula, do you have to determine which like function is above or below the other in order to use it?
Yes, because if you do it with the wrong one above the other one, you'll end up with the opposite of the correct answer, which is, still tells us something, but it's not the answer that you should be getting and not what they will accept on the AP test. If you flip them on the AP test, you won't get the credit for it.
So do we like graph it out, or do we just like put a table of values or something?
Yeah, either one. You either need to do a table with a couple of values and then prove that they don't intersect, if they don't intersect, or you can graph it out and show us a quick sketch. And there's lots of different ways you can show it, so long as you show it in some way or another. Should be good. Any other questions there before we do some of these?
Is it okay if you just like put the absolute value in the integral? Like so that you don't get a negative number?
Put an absolute value in the integral.
So then, like, pertaining to Yaya's question, like, so then you don't have to figure out which one's on top or on the bottom.
No, that won't work because, like in this case, right? If I took the absolute value of f minus g, about that. The absolute value of f minus g. Yeah, you're still going to have to split it up.
But if
Well,
they
actually,
didn't
no, I guess that would work. Yeah, it seems like, yeah, I think it would work, but they do not want you to do that on the AP test for sure. They want you to split it into the different ones and show. And beyond that, if it's not a problem that you can use a calculator on, you don't have a way to integrate absolute value. So,
Okay, thank you.
but you can't, what you definitely cannot do is you cannot just integrate whichever way you want, f minus g or g minus f, and then take the absolute value of it. That will give you incorrect answers if they cross through each other somewhere on the interval.
Awesome, thanks.
All right, any other questions there before we do a few? All right, so this right here is what I just sort of went through. If f is greater than or equal to g on the interval, then the area should just be the integral from a to b of f minus g. I think we should all be good there and ready to start. So what should we do first?
Figure out which one's bigger and which one's smaller.
Yeah, and we can do that with a quick sketch. X squared plus 1 looks like this, right? And negative x squared minus 1 looks like this. It doesn't need to look perfect, just needs to be generally accurate. And we're talking about between x equals 0 and x equals 1. So there's x equals 1. Which one is above the other one on that interval?
F of x.
F of x. Does it matter that one is above the x-axis and the other is below the x-axis?
Nope.
Not at all. Good. You were listening to all the stuff we just did. So we're going to integrate just from 0 to 1. X squared plus 1, the upper function, minus the lower function, negative x squared minus 1 dx. And we will combine those together into a nice simpler integral, x squared minus negative x squared, and 1 minus negative 1, giving us what? What is the integral of 2x squared plus 2?
Two-thirds x cubed plus 2x.
All right. We'll evaluate from 0 to 1. So 2/3 x cubed at 1 is just 2/3 plus 2, and then minus 0 plus 0. And 2/3 and 2 is 8/3, and we will say units squared. Make sure anytime we're doing this area that you indicate square units. Everybody good? Any questions there?
Do you have to write units out like completely, or can you just write like UN squared?
Yeah, that'd be fine. All right, let's take a look at this one. This one might take us a little bit more effort to figure out which function is above the other one. We know what sine x looks like, right? That's pretty straightforward. There's sine x. At least a basic rough sketch of it. We know it goes at max to a height of 1, right? And this is, that happens at pi over 2. And we're looking at 0 to pi over 4, so to right there. So there's sine. What about secant squared? What about just secant? What's the secant of 0?
Zero.
No.
Wait, right? 1 over cosine?
Yeah, cosine, and what's the cosine of 0?
Cosine of 0 is 1.
So 1 over 1 should be
Oh, okay. Yeah, sorry.
1, right? So secant of 0 is 1, and 1 squared is still 1. And if we think about, let's see, the cosine function, what does it do? It does this, right? Probably shouldn't have quite gone that far down, but it does that generally, right? This is what the cosine function does. So what happens when cosine or when you're taking the cosine of pi over 2, you get 0, right? Which means that the secant of pi over 2 would be 1 over 0, or infinity, which means what is secant and then also secant squared doing as it approaches pi over 2?
Asymptote.
Should be hitting a vertical asymptote. And so we know it's approaching it going up this direction and also this direction, negative pi over 2. Because if we plug in values of cosine, right, down to here, these are getting smaller. These are numbers between 0 and 1. And if I do 1 divided by something between 0 and 1, it gets larger, right? So our secant function or our secant squared function look like this. And so as we look for the area from 0 to pi over 4, which function is above the other one on that entire interval?
Secant squared.
Secant squared. So we got secant squared x minus sine x dx. And what's the integral of secant squared x minus sine x?
Tangent x plus cosine x.
Mm-hmm. And we'll evaluate that from 0 to pi over 4. Tangent of pi over 4 is?
One.
Cosine of pi over 4 is?
Root 2 over 2.
Minus tangent of 0 is?
0.
And cosine of 0 is?
1.
So we got 1 plus root 2 over 2 minus 1, which should be root 2 over 2 units squared. Good or no?
Good.
Perfect. All right. Let's move on to another one. And what do we notice right off the bat about this one that's different than all the previous ones? Anybody?
It's a curve and a line.
All right, it's a curve and a line. Okay, that's true. I guess this one was 2 curves. And this one was 2 curves, I guess. Okay, all right, okay, I can accept that answer. That's not what I was looking for. It is a curve and a line. What else is different about it?
There's like no set domain.
Yeah, there's no domain values, right? We're not saying this one said between x equals 0 and x equals 1. This one said x equals 0 and x equals pi over 4. Well, this one just says find the area of the region enclosed. So what we need to do then is we need to figure out what that region looks like. And there's 2 minus x squared, right? And here is y equals negative x. Pretend that all went through the origin there. So we have pretty clearly now, it looks like a defined region, but we don't know the ending points of it. And so we need to find what these intersection points are. Does that make sense to everyone?
Yes.
And how do we find where 2 functions intersect with each other?
Set them equal.
Exactly. So we should get 2 minus x squared equals negative x. And if this is the AP test, you need to show how you're finding those intersection points. Also, if it's my quiz, you need to show how you're finding it, and then solve it. So how do we solve that? That's just a quadratic, right? So we know that those are intersecting at -1 and 2. Everybody agree with that?
Yep.
Wonderful. So all we have to do is integrate from -1 to 2, the upper function. Which one's the upper function?
The parabola.
The parabola. Minus the lower function, which is the linear one. And does it matter that for part of it, they're both above the x-axis, and for part of it, one's above and the other is below?
Nope.
No, good. I'm glad we went through all that and people listened about that. Okay, so now we just integrate. What's the integral of 2? 2x, right? Integral of -x squared is -x cubed over 3. And this becomes minus negative, right? That becomes plus x. So we'll call that plus x squared over 2. And we'll evaluate that from -1 to 2, giving us, let's see, 2 times 2 is 4, minus 8/3 plus 2 minus -2 minus -1/3, so plus 1/3, and then plus 1/2. Good or no?
Good.
All right, so simplifying down, we got 4 plus 2 is 6. Right? We got 6 plus another 2 is 8. And then we got minus 8/3 and minus 1/3. That's minus 9/3 or minus 3. And minus 1/2. So 5 minus 1/2 is 9/2 units squared. Good or no? Any questions, any issues, any problems with that? Everybody feels okay about that?
Yes.
Wonderful. All right, let's do another one. Don't worry, everybody. We only have 35 minutes to go. Could be worse. What should we do here?
Make a graph.
Make a graph. All right, so 2 cosine x, right? Something like that. And x squared minus 1, something like that. We've got a region between them. Yeah, and we want the area of that region. So it should be an integral of the upper function, which is cosine function, minus our lower function, which is our parabolic function. Question though is, where do they intersect? And we find that by setting 2 cosine x equal to x squared minus 1. That's going to be an equation that you're going to have a lot of difficulty solving by hand. So we will use our graphing calculator to find where those intersect. So hopefully you remember how to do that from last quarter, especially since my graphing calculator is not working on my laptop still. But you want to graph 2 cosine x, you want to graph x squared minus 1, and you want to hit second, calculate, and then look for intersect. And then you'll be on one or the other of the 2 curves, scroll to the left of an intersection point, hit enter, scroll to the right of that same intersection point, hit enter, and then hit enter a third time, and it should give you the value. And we'll note for both of these, and in fact, maybe I'll throw this up on Desmos real quick. We'll note that both of these are even functions, right? 2 cosine x, symmetric across the y-axis, and x squared minus 1, also symmetric across the y-axis. So the points of intersection should be numerically the same, right? Positive or negative. Looks like it's about 1.265. And somebody is, I'm sure, doing this on their graphing calculator and is going to give me an even more accurate value for that.
I got 1.2654.
26542.
Yeah.
It only gave you 5 decimals. I usually have 6.
Oh, 237.
237,
Yeah.
even better. All right. And so if this was the AP test, you would show the graphs to show which one was above the other. You would show that you set these equal to each other. You'd write this equation. You'd use your graphing calculator to solve it, and then you'd write these values below. And then you'd write out your integral. And then you would, since this is an easy function to integrate, right? It's 2 sine x minus x cubed over 3 plus x squared or plus x. But evaluating that at these values, you're not going to want to do without your calculator. So if this was a calculator question, which it would be, you'd show the equation, show the intercepts, show the integral, and then just plug it in and approximate it. And you'll never want to truncate these values until your final answer. Don't round anything until the very end. And at the end, if you want to, you can round to 3 decimals, or you can write out everything and give you. Always round to at least 3 decimals at the end. Don't do it before the end. So what do you guys get?
$4.9949.
4.9949. And I'll just round it to 4.995 because this is the test, and we'll say that 3 decimals is what they want. Or better, 4.9949 would have been fine too. Any questions or issues with that problem?
No.
Cool. All right. Let's just do one more. This will be the last problem we do today. We've got the area of the region in the first quadrant bounded by root x and y equals x minus 2. Right, it's this region that I've sort of outlined in red, the region in the first quadrant. Yeah? Everybody agree there?
We agree.
Oh, good. Okay. What is different about this region than every other region that we have dealt with so far? Okay, let's try this again. starting at the beginning here and going all the way to the end of my interval, which function represents the top of the region? Doesn't square root of x? This is always the top of this region. Pick an x value in here. Pick an x value, right? What's the top of the region? It's from square root of x. True?
Yeah.
You all agree? Okay. What's the bottom of the region? Pick this x value. What's the bottom of the region?
The x.
The x-axis.
The x-axis. Pick this x value. What's the bottom of the region?
The linear equation.
The linear equation x minus 2. Something different. So the bottom of this region is not always defined by the same function. You all would agree with that, I hope?
Mm-hmm.
That's a problem. Right? I don't have f of x minus g of x. I have f of x minus g of x for part of it, and I have f of x minus some other g of x for part of it. So what do you think we should do? Maybe separate it at that point? Yeah? What is that point where it switches from the x-axis to the other function? This would be at x.
Where? The intercept?
Yeah, and where is that? Where does this line cross through the x-axis?
X equals 2.
Exactly. So if I want to find the area of the whole thing that I outlined in red, I need to do this blue and this green piece separately. So that's what we're going to do. So for the blue piece, we need to integrate from what x value to what x value?
0 to 2.
Okay, we need to integrate from 0 to 2. And what's the upper function? Root x, right? And what's the lower function? It's just the x-axis. So do I need to subtract anything?
Nope.
No, it's just root x. All right. Now to do the green section, we're going to add the integral from 2 to this endpoint. Oh man, now we got to find this endpoint, right? We got to figure out what this x value is, where root x and x minus 2 intersect. When is that in the case? At x equals
4.
Yeah, I mean, we should just be able to see that that's 4. Just by a little bit of inspection there. If you had to, you could square both sides of it to get x equals x squared minus 4x plus 4, and then turn it into a quadratic and solve, and you'd get x equals 4, and you'd get x equals -1, which would be an extraneous solution, and blah, 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 blah. Okay, but hopefully just from inspection, we see that that's x equals 4. So we'll go up here and say we're going to integrate from 2 to 4. And the upper function is now the square root x function. And what's the lower function?
X minus 2.
Minus 2. Everybody agree with that? So a little bit of a pain to set that up, but it could be worse, right?
Indeed.
Okay. So what's the integral of root x?
2 over 3x to 3 over 2.
2/3 x to the 3x, right? So we got to evaluate that from 0 to 2. And we need to add to that. We just did that integral, 2/3 x to the 3/2. What's the integral of minus x? That should be minus x squared over 2. And the integral of plus 2 should be plus 2x. And this will be done from 2 to 4. Everybody agree there?
Yes.
Perfect. Okay. Now just a bunch of arithmetic. So evaluating 2/3 x to the 3/2 at 2. Well, the square root part of that is square root of 2. And if you cube the square root of 2, what do you get?
2 root 2.
2 root 2, and then that times 2/3 ought to be 4 root 2 over 3 minus, and then 0 to the 3 halves is 0 times 2/3 is still 0. First part of that is that, and we will add to that all of this junk in here. So 4 to the 3 halves, well, that's the square root of 4 is 2. 2 cubed is 8 times 2/3 is 16/3. Minus 4 squared is 16 over 2, so minus 8. And then plus the 2 times 4 plus 8. And then minus all of this evaluated at 2. We just did 2/3 x to the 3 halves at 2, right? That was 4 root 2 over 3, so we can skip having to fuss with that. 2 squared is 4 over 2 is minus 2, and plus 2 times 2 would be plus 4. Good or no?
Good.
All right, we should have a bunch of stuff that we can just ignore, right? The minus 0 we can just ignore. The minus 8 plus 8 we can just ignore. This minus sign gets distributed to the 4 root 2 over 3, which makes it a negative 4 root 2 over 3. And this is a positive 4 root 2 over 3. So I can cancel those out. So effectively, I'm just left with 16/3 minus negative 2 plus 4, or 16/3 minus 2. Or 10/3 units squared. Good or no? Any questions or issues with that?
Can you also do, I know this is, you could either like do both these. Can you do the integral from 0 to 4 of the square root of x minus the integral of from 2 to 4 of x minus 2?
Oh, what a great idea. Goodness, good thing we have so much time to do this problem multiple times. I like that. Yeah, let's do this problem again. Yeah. And don't worry for all of you complaining that he just asked this, but we were going to do this problem multiple times today either way. All right, I still want this same region, but I don't want to split it here. Maybe I wanted to not split it at all. Suppose, and I'm gonna, who was that was just talking? It doesn't tell me who it is when you're talking.
Oh, Jack.
Jack? Is that what you said? Jack? Yeah. Okay. You sort of cut out when you just said your name. So I think you said Jack. Jack had a great idea. And we're going to use his idea as the last way that we're going to do this one. But the first thing we're going to do is we're going to look at another way. I could, instead of finding this red region by just finding the red region, I could find this green region first. And then if I found that green region, I could subtract off this blue piece. And wouldn't that be the same? That's very similar to what you were just saying, except you were having us do it over here, right? Which is actually the easiest way, which is why I'm going to do this one second. But does everybody see that if I found the whole green area, I could knock off this blue piece and still get the red?
Yeah.
Yeah, right, same functions, root x, x minus 2. This is still 2, this is still 4, etc., etc. Okay, so what's the area of the green region? The upper function is always root x. The lower function is now always this linear one. We're no longer worrying about the x-axis. And we just integrate from 0 to 4. But we have to knock off the blue region. And There's two ways to find this blue region. One is to do the integral from 0 to 2 of x minus 2, and that becomes a negative value, so we'll just have to subtract the opposite of it. But the other way is to recognize that what is this blue area?
Triangle.
It's just a triangle, right? With an area of 1/2 base times height. Base is 2, height is also 2. So we don't even have to do the integral there. And what does this give us? Gives us, now the section in red is this whole thing. So the integral from 0 to 4 of this is, that's still 2/3 x to the 3/2, right? Minus x squared over 2 plus 2x from 0 to 4 minus 2. And what's 2/3 x to the 3/2 at 4? We did that a minute ago, right? That's 16/3 minus 8 plus 8 minus a bunch of zeros minus 2. We got 16/3 minus 2, which is once again 10/3 units squared. Everybody good with that?
Yep.
All right. Oh, let's do this one again. Now we're going to do this the way Jack really wanted to do it. So there's root x, there's x minus 2. This is the region I'm looking for, but instead, I'm going to find this region. And then I'm going to knock off this green triangle. You guys all see that that would be the same exact thing, right? Finding all of this and taking off the green triangle.
Yes.
So what is the blue one? Well, the upper function is always root x, and the lower function is always just the x-axis. So I should now be able to just integrate from 0 to 4 only root x dx and subtract off that triangle in green. Well, if this was 2 and this was 4, and this height up here, well, if I plug in 4 to root x, this height up here is 2. So it's just 1/2 base times height. And now we've got 2/3 x to the 3/2 from 0 to 4 minus 2. And now we've done it multiple times. 2/3 x to the 3/2 is just 16/3 minus, plug that in at 0 is 0, minus 2, which is still 10/3 units squared. And that's what you were saying, right, Jack? That's the one you wanted to do?
Yeah.
Yeah, that's the easiest one, right? And you could, like you were saying, you could do the integral of x minus 2 from 2 to 4, which would be this, that's the same as this area in green. X squared over 2 minus 2x evaluated from 2 to 4, which is some arithmetic that's not too terrible, but more annoying than just finding the area of the triangle. So you could find the area of the triangle, or you could find the area using the integral. That was a great idea. And that's exactly what we're going to do. So we were able to do this one in 3 different ways. And that, as I promised, was the last problem we were going to do today. We were going to do it 3 different ways. So tomorrow, we're going to add in this last little thing about area where we do some integration in terms of y instead of in terms of x. And once you've done with that, you'll be able to complete everything on the area paper. But that's it for today. Any questions on anything we've done today?